Hello students, it's prime time. In this chapter, we will explore the world of numbers by understanding how they can be divided and multiplied in various ways. We will learn about prime numbers, composite numbers, and how these concepts help us solve problems in mathematics. Now, let's dive into our first topic, common multiples. These are numbers that are multiples of two or more numbers. For example, the multiples of 3 are 3, 6, 9, 12, and so on. Similarly, the multiples of 4 include 4, 8, 12, 16, 20, and so on. When we look for common multiples of 3 and 4, we find numbers that appear in both lists like 12, 24, and so forth. Moving on, let's talk about common factors. These are numbers that divide two or more numbers exactly without leaving a remainder. For example, the factors of 12 include 1, 2, 3, 4, 6, and 12. Similarly, the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. Now let's explore a game called Jump Jackpot. In this game, Grumpy hides a treasure on a number, say 24. Jumpy can only land on multiples of a number he chooses, like 4, 6, or 12. To win, Jumpy must land exactly on 24. If Jumpy picks 4, he lands on 4, 8, 12, 16, 20, and finally 24, winning the treasure. If he picks 6 or 12, he also wins because these numbers are factors of 24. But what if there are two treasures? Let's say one is on 14 and the other on 36. Jumpy needs to pick a number that will allow him to land on both. If he picks 7, he lands on 14 but misses 36. However, if he picks 2, he lands on both 14 and 36, winning both treasures. Here, it is clear that if he picks 2, he can land on both 14 and 36. Next, we will learn about prime numbers. A prime number is a number greater than 1 that can only be divided evenly by 1 in itself. For instance, 7 is a prime number because the only numbers that divide 7 evenly are 1 and 7. Now let's discuss composite numbers. A composite number is a number that has more than two factors. This means it can be divided evenly by 1 itself and at least one other number. For example, 12 is composite because it can be divided by 1, 2, 3, 4, 6, and 12. It's time for the fig picking game. Guna and Ashu want to pack figs from their farm. Guna decides to put 12 figs in each box, and Anshu wants to put 7 figs in each box. They start arranging the figs in rectangular shapes. Guna's arrangements include 3 rows of 4 figs each and 2 rows of 6 figs each. Anshu can only arrange his 7 figs in one row of 7 figs. Understanding the concepts, we see that numbers like 12 can be arranged in many ways because they have several factors. In contrast, numbers like 7 can only be arranged in one way, meaning they have just two factors, 1 and 7. About 250 BCE, a Greek mathematician, Eratosthenes, developed a method to find the prime numbers up to 100. In this method, we prepare a table of numbers from 1 to 100 and proceed as follows. Step 1. Cross out 1 as it is neither prime nor composite. Step 2. Mark 2 and all the multiples of 2. Step 3. Mark 3 and all the multiples of 3. Step 4. Mark 5 and all the multiples of 5. Step 5. Mark 7 and all the multiples of 7. So the prime numbers are the unmarked ones. Now, let's move on to co-prime numbers. Co-prime numbers are two numbers that have no common factors other than 1. This means they can't be divided by any of the same numbers except for 1. For example, factors of 9 are 1, 3, and 9. Factors of 8 are 1, 2, 4, and 8. 9 and 8 cannot be divided by any common number other than 1. To make it simple, Think of co-prime numbers as two friends who like different things and don't have anything in common, except they both like ice cream, which is like the number 1 in this case. Now, let's move to prime factorization. When we break down a number into its individual factors, those factors are called prime factors if they are prime numbers. For example, the number 56 can be expressed as 8 times 7, which can further be broken down into 2 times 2 times 2 times 7. Therefore, the prime factors of 56 are 2 and 7. Every number greater than 1 can be broken down into prime factors, a process known as prime factorization. However, the number 1 does not have a prime factorization because it is not divisible by any prime number. Let's look at prime factorization of a product of two numbers. If you have 72 candies, you might first split them into two smaller bags, one with 12 candies and another with 6 candies. You can further split the bag with 12 candies into 2 and 3 candies. The bag with 6 candies can be split into 2 and 3 candies. By combining the candies from both bags, you can find that the prime factorization of 72 is 2 times 2 times 2 times 3 multiplied by 3. Now, let's see how to use prime factorization to check if two numbers are co-prime. Suppose you have two bags of candies, one with 56 candies and another with 63 candies. You break down the 56 candy bag into 2 multiplied by 2 multiplied by 2 multiplied by 7 candies, while the 63 candy bag breaks down into 3 multiplied by 3 multiplied by 7 candy. Since they share a common type of candy, which is 7, they are not co-prime. Let's take another example with bags of 80 candies and 63 candies. You break down the 80 candy bag into 2 multiplied by 2 multiplied by 2 multiplied by 2 multiplied by 5 candies. The 63 candy bag is made up of 3 multiplied by 3 multiplied by 7 candies. When you compare them, you see that both breakdowns have no common candies. Since they don't share a common type of candy, they are co-prime. Since they don't share a common type of candy, they are co-prime. Using prime factorization to check if one number is divisible by another. Imagine numbers as baskets filled with fruits, where each type of fruit represents a prime factor. To check if one basket can fit into another, you need to see if all the fruits of the smaller basket fit inside the bigger one. For example, is 75 divisible by 21? The 75 fruit basket has 3, 5 and 5, while the 21 fruit basket has 3 and 7. Since the 75 fruit basket does not have 7, it means it cannot fit inside the bigger one completely. So 75 is not divisible by 21. To check if a number is divisible by 10, simply look at the last digit. If the last digit is a 0, the number is divisible by 10. For instance, 8560 ends with 0, so it is divisible by 10. For divisibility by 5, look at the last digit. If the last digit is a 0 or 5, the number is divisible by 5. Again, looking at 8560, it ends in 0, so it is divisible by 5. To check if a number is divisible by 2, see if its last digit is even. The last digit of 8560 is 0. Which means it is divisible by 2. For divisibility by 4, look at the last two digits of the number. If the number formed by these two digits is divisible by 4, then the whole number is divisible by 4. For example, 8536, watch video lectures, and since 36 divided by 4 equals 9 of this chapter with no remainder, 8536 is divisible by 4 in your school exams. Finally, for divisibility by 8, check the last three digits. You also get amazing courses. If the number formed by these digits is divisible by 8, then the whole number is divisible by class 6. For example, in 8560, the last three digits are 560. Since 560 divided by 8 equals 70 with no remainder, 8560 is divisible by 8. To wrap it up, we have explored the fascinating world of numbers, focusing on concepts like common multiples, prime and composite numbers, and prime factorization. By understanding these concepts, we can solve various mathematical problems effectively.